of refrigeration, we use the certain different type of the salts. Like is sodium chloride. This is the chemical formula is NaCl. Calcium chloride, CaCl2, saltpeter. I like three types of the solvent which is dissolved in water. When the sodium chloride is dissolved in water, NaCl, it absorbs the heat from the water and it reduces the temperature of the water up to 20 degrees Celsius. वाटर प्लस NaCl, सोडियम क्लोराइड को अगर हम वाटर के साथ जोड़ देंगे नमक को, सोडियम क्लोराइड इज द नमक, देन इसका जो टेम्परेचर है लगभग -20 डिग्री तक कम किया जा सकता है. देन इट विल बी वी कैन reduce the water up to 20 degrees Celsius. Now, if we use the calcium chloride, CaCl2, then this solution of the water is reducing the -50 डिग्री सेल्सियस. कैल्शियम क्लोराइड का उपयोग करने से 50 डिग्री सेल्सियस तक, मीनिंग ऐसा है कि आप 5 डिग्री सेल्सियस भी कम हो सकता है, 10 भी हो सकता है, लगभग 50 डिग्री तक, अप टू 50 डिग्री सेल्सियस तक हम लोग कम कर सकते हैं. दिस मीन्स दैट द when mix the water, the calcium chloride and sodium chloride, the water temperature is completely reduced and the evaporation work will done. But for not suitable for the commercial work, therefore this commercial work purposes we use the fluid for the coolant circulating the refrigeration system. We will discuss later. Phase. Now the second term is refrigeration is change in phase. We know that the ice in the solid form, water is in liquid form, and the vapor is in gaseous form. If the temperature is 0 to 4 degrees Celsius, positive, then the ice is uniform in state, in solid state, but above the 4 degrees Celsius, it will be melt and it form in liquid form. But at a point of the water where the vapor, liquid and solid phase is at a point which is known as the triple point of water. In which water, if this point, the below, the liquid is formation is transformed to in solid form, not fully, but it will be transformed. This type of the form is known as the solid plus vapor phase. And if this form is liquid, here the liquid plus vapor phase, from the TS diagram of the refrigeration due to phase change, here liquid plus vapor phase, either solid plus vapor phase. This means here vapor is present always. Vapor is present always here. Due to the below side, this is solid, and the triple point above side, which is liquid. And this is the sensible heating. Therefore, when the temperature increases due to sensible heating means the not applying the temperature, which is only the internal energy, and transform the heating and transform the energy from the ice to water. And therefore, the ice to water, then this diagram, TS diagram, is vapor phase is enclosed in this cycle. And this diagram, the solid phase is below the triple point and the liquid phase is above the triple point, and vapor phase is present always in between the diagram circle. And this is the critical point. This portion is the superheated state. superheated region. Now, for the triple point of the water, which means the liquid vapor and the solid phase is at a point. Ice is transformed the solid to liquid phase. This transformation is known as the fusion phase. Now the QC, which is the rate of change, Q dot C meaning rate per unit time, मतलब mass flow rate per unit time. Is like this. The Q dot, this is the M dot is the rate of the fusion, meaning the fusion rate of the ice per second. M dot into HSF. HSF is the enthalpy. H is denoted as the enthalpy, and here this diagram S is denoted as the entropy. HSF is the enthalpy of the fusion, and we know that at the standard temperature and pressure, the HSF enthalpy of the fusion of the ice is 335 kilojoule per kg or 80 kilojoule per HSF is 335 kilojoule per kg or 80 kilocalorie per kg. If the ice is transformed from the solid to direct vapor phase, which is the solid is in state below the triple point and the vapor is in state above the triple point. Here the mixing of the vapor, but the solid to vapor, when suddenly applied the high energy of the apply on the ice, then it will not convert to liquid, directly to vapor. And this means that QC equal to M dot, which is the rate of change of the in ice, and the HSE, which is the sublimation of the enthalpy of the sublimation of ice. For example, for a solid carbon dioxide, which is also known as dry ice, which value is the HSE is enthalpy of the carbon dioxide, solid carbon dioxide is 573 kilojoule per kg in 1 atmospheric pressure. Okay, 1 atmospheric pressure, this is the enthalpy is 573 kilojoule per kg, and it will maintain the temperature of the refrigeration is like a refrigeration is used for the solid carbon dioxide or the carbon dioxide it will flow is like a fluent. Then it will maintaining the temperature of minus 78.5 degrees Celsius. Here the liquid to vapor phase transformation of the refrigeration fluid. From the TS diagram, we go to TS diagram as like a critical point. In between, in center of the critical, there are the right side. This is the superheated region, and this is the subcooled region. It's like a liquid region. Here gaseous region, here the liquid region. Gaseous region is denoted by G, and the liquid region is denoted by F. This value is here the enthalpy or entropy value is more than this value. In this diagram, TS diagram of the curve of the TS diagram, the point of the F in G is the G value is greater than F, and this is known as the enthalpy of the superheated region, enthalpy of the liquid region. Therefore, here the transformation of the heat in the refrigeration fluid or refrigerant, this M dot is the mass flow rate of the fluid, and Hg, which is the superheated region of the at a point of the diagram, and Hf is the liquid region of at a point of this, and this is the temperature. At a constant temperature it will flow from this. And if minus of the enthalpy from higher enthalpy to lower enthalpy, therefore this value is M dot into Hfg. If we put the point Hg and less than Hf, then we got the same value like our steam table. Hfg value is the same, and we calculate the liquid to vapor region of this. Now we go to the throttling process. Here TP diagram, there are two curves, upper curve, and this name is the inverse curve, and there are two curves which is the upper and lower curve, where the 3 points TB, TA and TC. TC is the lower temperature, TA is the middle, or I indicate the is a horizontal line which is denote the I, and TA and TB is the upper temperature. H is the enthalpy. Is suppose here both are the curve enthalpy are constant. Enthalpies are constant. Here Pi is a parameter of the pressure, and therefore if the fluids at high pressure is expanded through a valve, there are three effects are expected depending upon the initial and final conditions. Now the three conditions are what? The first condition is T is greater than Ti, and second is T, temperature of the E, is equal to, this is the evaporation temperature, E is the equal to Ti, or third condition is T is less than Ei. Here the temperature Ti, TA, TB, TC is the valve temperature, valve opening temperature, Ti is the inlet temperature, and TE is the three conditions of TB, TA and TC. As the throttling process, pressure decreases and temperature increases until the maximum. As like pressure P decreases in symbol. In Joule-Thomson coefficient mu equal to, this is the del T by del P when the enthalpy is constant is 0, and this point is known as the inversion. As a TP diagram shown, the portion is PT, this point is called the inversion point. For the refrigeration point of view, the pressure value of the mu, which is the Joule-Thomson coefficient mu, is taken as positive for cooling, where the Joule-Thomson effect coefficient mu equal to del T by del P when constant enthalpy, and here the value of the effect is 0, where this is known as the inversion point, as in figure. Here the TP diagram, the downward points shows the pressure point PC, PA, PB, and PI is the inlet pressure, and the TB, TA, TC, which is the in y-axis shown in the temperature, and pressure is in x-axis, and here throttling devices, where the inlet arrow is the right to left side, which is the this process, overall this process is known as the throttling process, and this is the small diameter which is suddenly open the device, then the pressure reduces and decreases the pressure until the maximum temperature achieved of the refrigerant. And it will the next discuss in the next class, where the refrigerant is goes to the super heated region, from the subcooled region to superheated region, which is discussed later. Thank you.